Okay, so hopefully this is one of the last lessons I'll have to record without my wearable mic, but in the meantime, we're going to have to struggle through. Um, we're going to be talking about the basics of three-dimensional shapes. We've used a lot of these vocabulary words already. Um, we know that the flat surfaces that make up a solid is called a face. The corners where the faces meet is called the edge here. So see where two faces meet. And a vertex is where three of the faces intersect, or three or more faces actually if it's a pyramid with more than three sides. So this would be a vertex, this would be a vertex, etc. All right. The basic four groups of solids is a prism. Okay, that's two parallel congruent faces. Okay, and we call these bases. So we've got a face here and a face here. We know those are the bases because they are congruent. Okay, and all the things that connect these two bases are parallelograms. Okay. It's also, the prism is named for its base. So like, for instance, this would be a square prism. A pyramid has a base, which is a rectangle, square, pentagon, anything like that. And then all these triangles come up together to form up to the top up here at that vertex. Okay? And so all the sides are triangle faces, and then it's named for its base. Okay? A cylinder is just like a prism, except that its bases are circles. Okay, so it's two circles with basically a rectangular tube wrapped curled around to join them, and a cone is just like a pyramid in that it has one base and then it comes up to a point. Okay. And then all these are three-dimensional pictures. You can tell the way you draw a three-dimensional picture is you just make anything that you wouldn't technically be able to see if it weren't, if it were solid, you make that dotted. So for instance, in this one, we've got a triangular prism. We can't see this back edge here because if this were solid, we would it would be blocked from our view. So that's basically how you draw a pyramid. Same thing here. This edge here is blocked from our view, so it's a dotted line. Okay? And then all of these solids break out. Like if you cut them apart and lay them out flat on the ground, they make what we call a net. So here's an example of how, like, cutting apart this triangular prism. So I cut across the triangles, and they come open. Then I cut across this top, and the sides fall open, and it makes what we call a net. Okay? So prisms are always going to have the two bases here, and then however many number of sides the bases have, that's how many rectangles are going to join it between it. So in this case, a triangle has three sides, so it's going to need three rectangles to join all the sides together to make it a prism. All right. Same thing with this is a triangular pyramid. So if I basically unhinge it at the top, so I just basically took apart the thing that holds it together at the top point, all the sides fall open. So I've got the base in the center here, and then however many sides the base has, that's how many triangles come together around it. Okay, so a pentagonal pyramid would have a pentagon in the middle with 5 triangles around the outside. Right? Now a cylinder maybe is the trickiest one, but you got to think of it like a tuna fish can. You're going to use a can opener and cut away the top circles here and here, okay? And then when you take away those circles, it's going to leave this band in the middle. If you just cut it up through the center and open it up, it makes a rectangle. So its net is going to be the two circles that make up the top, and then the rectangle that goes around the circles. Now, if you think about it, this rectangle has to go exactly around the circle. It has to fit exactly. If it didn't, like all the tuna fish would leak out. So the length of this rectangle is the same as the circumference of this circle. Right? We will pick that up a little bit later too. All right? So again, when you lay it out flat, cut it apart and make it lay down flat, that's called a net. All right? So I have a couple examples, like for instance, we've got a rectangular net. Ignore these little tabs here, these little things, because those are just to fold in, but watch. When you fold up a net, ignore those little tabs, it makes a rectangular prism. Same thing here. If I fold, I've got my three rectangles, my two bases, right? Same thing here. I've got, well, this one's a little bit different. Instead of just putting all the triangles around the outside, they put two together. But if I fold them up, I have a rectangular prism. Okay? All right. Then, okay, an orthographic drawing is looking at a shape from different perspectives and drawing what you see from that perspective. So for instance, here we have this rectangular pyramid. If I looked just at the front, like this is tipped a little bit to the side, but if I tipped it up so that all I could see was straight on the front, it would look like a triangle. Same thing with the back. Now, if I looked at the top, okay, if I looked straight down on it, I would see the vertex, right, and the four sides that come out here. And then the base, that's a rectangle. So can you see that I'm looking straight down on it? Okay? Obviously, the bottom, the left and right sides are all just then basic shapes. Okay? So take a second and see if you can come up with an orthographic drawing of a cone, a cube, a triangular pyramid, and a pentagonal prism. Okay. Here's my version of this. You'll notice on the cone, the top is going to have one little dot to show that point. The bottom, though, does not, because you can't see the cone part. The side and the front are identical. Same thing with pretty much all of these. The side and the front are the same. And then we have a cylinder down here. All right. Now the homework tomorrow is in the book, so if you want to bring your book, that would be great. And I have some in class.